In the previous videos, we mentioned about the detailings of the beams, slabs, columns, and also the foundations. The detailing provides a lot of informations, particularly in terms of the reinforcement bar to be provided within the structural element, as well as their dimensions. The illustrations given in the detailing, together with the text that are used to complement the understandings of the readers of the technical drawing, allow different parties along the pipeline to contribute in accomplishing the reinforced concrete structures in the realities. Not only we need to provide neat detailing, good technical insight, as well as understanding in terms of the construction process are equally important. You need to be aware of the working process, as well as know how you can ensure the fabrications of the structural element to be done in the productive and effective manners. We also mentioned that you need to strike a balance in between the economic usage of the material versus the practicality in terms of the supervision of the progress of the project, as there are various parties playing their roles throughout the construction process. The informations need to be effectively transferred among different parties, that different parties may extract the necessary informations to their priority in accomplishing their tasks during the constructions of the structures. In these videos, we're going to proceed with our discussions regarding the detailings of the staircase. We will demonstrate some examples of the staircase detailing for better understanding. For the detailing of the staircase, you need to clearly indicate its locations, its details in terms of the dimensions for the riser, for the steps, as well as the floor directions in the key plan. Next, you provide detailings for the staircase. In the existence of the landing beam, you need to provide details for the landing beam. This may seem to be simple. There are a lot of information you need to cross-check in order to ensure the consistency and coherentness in terms of the design. You first need to know how to design a staircase. This normally you can acquire from the references of the reinforced concrete design. A typical references will have a chapter discussing the staircase design. As far as the technical drawings concerned, you will need to first acquire the information from the architectural drawing. Most likely you're going to have those from the cross-section of the building. Typically, architect will have a specific cross-sections cutting through the parts of the building where it can easily show the staircase. Taking this as an example, you'll be able to see the staircase here. Normally, the details of the staircase are clearly indicated. It is either clearly specified in the architectural floor plan, or it may be given in the cross-section of the building. And normally, the dimensions given in the architectural drawing in terms of the cross-sections should be in line with the informations as given in the specifications for the staircase. However, it is always a good practice of you do some simple check against the details as given in the architectural floor plan. This is another example of the staircase as given by the architect. The details are given and the dimensions is given. In fact, this part is also meant for the staircase, although it is not clearly drawn, but the details is given in the architecture floor plan. If the exact dimensions is not properly illustrated by the cross sections of the building, you will have to sketch it yourself in accordance to the details given, to be closely checked side by side with the plan view as given by the architectural floor plan. You need to make sure the shapes which you view from the side of the staircase needs to be in line to the plan view as given by the architectural drawing. In the case that the information is not in line, you should cross-check with the architect for further clarifications. Normally, the architect will indicate to you which part of the staircase are to be designed by the engineers, which in this case, the RC staircase are to be designed by the engineers. And for the handrails, this is not the RC part, thus you don't have to design that. Now let us look at the examples of the detailings of the staircase. In order for you to produce the staircase, first you need to have the shapes of the staircase required that you acquire from the architectural drawing, and then you're going to refer your staircase here in accordance to the structural key plan that you have established. Make sure the grid line here is in consistence with the structural key plan that you produce. Now that you have all those ready, we're going to look into detail parts by parts. First, you need to identify the floor level. For this staircase here, the ground floor level it will be here, and the first floor level it will be here. That means you will require 2 landing beam here as well as 2 landing slab here. This design of staircase will go up in this manner, up here until here, where you reach to the first floor level. Make sure the dimensions given is in accordance to the sections given by the architect, and make sure this is in line with the specifications given by the architects. And then, by the time that you are producing the detailings for the staircase, most likely your key plan has already been established. Check the positions of the staircase in accordance to the grid line. Identify the size of the beams where the staircase is going to meet at different floors. Draw the incoming beam in the appropriate size. As for the stair, the amount of reinforcement bar is very much dependent on the effective spans of the staircase. The effective span, it will be considered as the distance between the 2 beams for the staircase. For this case, the effective span is more than 4 meters, and for this case, the effective span is longer, which is more than 5 meters, and the effective span here is shortest, and so on so forth. The longer the effective span, it will be more critical, which most likely you require a thicker staircase to ensure it passes the moment resistance as well as its deflections are within the limits, which in this case, because of the span here is the longest, the staircase here is the thickest. In fact, you can actually standardize the thickness of the staircase throughout the entire building. That one is dependent on your design, but on basis of the practicality, maybe you should just standardize it to become 175, meeting the requirements of the staircase of the longer span, so that none of the staircase here will fail. Next, you need to provide the reinforcement bar. Normally, there will be the reinforcement bar at the bottom of the staircase, and there will be top reinforcement bar near to the support. The concept is very similar to the slabs, only that the orientations of the staircase is inclined, as it provides access from a floor to another floor. Be careful with the main reinforcement bar and the secondary reinforcement bar. For the most efficient resistance to the moment, the main reinforcement bar should be placed at the situation depth with the largest effective depth as possible. This makes this to be secondary reinforcement bar, which can be the nominal reinforcement bar, meant for controlling the cracks, as well as positioning of the longitudinal reinforcement bar. Clearly indicate the size and the spacings of the reinforcement bar. The label here, it will be on basis of the reinforcement bar provided for the slabs, which is also written in the form of the size of the bar and the spacing of the bar. And you have top reinforcement bar at the support. Clearly indicate where you can have the top reinforcement bar be removed. This length is normally about 1/3 of the effective span of the staircase. You can round it up to some round number for a higher degree of conservativeness. Clearly indicate the thickness of the slabs of the ground floor, the riser, the steps, the thickness, the anchorage length, and how the reinforcement bar should be laid. Remember that the reinforcement bar can only go in the straight directions for the maximum performance instead of being bent here and there. As for the arrangement of the reinforcement bar, it should be something like this. You have a straight bar being bent in these directions. You also have a straight bar here being bent in these directions. There will be a straight bar here being bent outward. There will also be the spread bar being bent in these directions, as well as the top bar here being bent in these directions. You will proceed with the similar design for the subsequent spans of the staircase. As you can see, this level is the ground level, and this level, it will be the first floor level. That means these two landing slab is going to be at the intermediate height of the building, where there will be landing beams, and this landing beam is not seen in your structural key plan because the key plan are meant for the ground floor and the first floor. Therefore, you will need to clearly indicate where are the locations of the landing beams. You also need to provide the details for the landing beam, which should theoretically look something like this in accordance to the grid line provided. Let's say now we take this as an example. You need to provide the detailings for the beam in accordance to the proper dimensions, as well as the grid line, and the numbers of the landing beam needs to be clearly indicated. There will be the main reinforcement bar as well as the shielding, and to indicate the existence of the columns or stiffeners. The landing beam is very important as it will govern the load resisting mechanism of the staircase, whether it is simply supported or is it going to be cantilevers. Normally we are more concerned about the cantilever design. We prefer to have the landing beams, and when it comes to the cantilever design, the arrangement of the reinforcement bar may vary significantly, where you're going to see extensive reinforcement at the top surface of the staircase. If you could, always try to find solutions where the span of the staircase can be done in the simply supported manner by providing a landing beam to be supported by columns. If the columns are not allowed, you find some way to support the landing beam, probably by some stiffeners which are to be hid under the staircase or within the walls so that it is not obviously seen and so that it doesn't affect the aesthetic view. It is possible for you to design as a cantilever, just that you need to be extra careful with the design. And the good thing about simply supported staircase, the amount of reinforcement bar is not that much. You don't have to go for a high level of conservativeness. And normally the spans of the landing beam are relatively short, which is governed by the width of the staircase. I would say that that would be an economical design. Now that we have covered the detailing of the staircase, you know that there are a lot of things that you need to refer. First, you have to refer to the architectural drawing, and then refers to the sections of the buildings in order to see how the staircase actually looks like. If the sections do not provide you the appearance of the staircase, you will need to draw yourself in accordance to the specifications given by the architect. And then you will need to make simple calculations to check if it really fits to connect different levels of the building. Next, you will need to decide whether you want to design the staircase to be cantilever or to be simply supported. Be careful with the reinforcement bar arrangement, as the cantilever staircase will have the reinforcement bar arranged differently than the simply supported staircase. Of course, if you can, try to go for the simply supported staircase. It will be more economical. It is always a good practice of you to standardize the thickness of the staircase throughout the entire building in order to avoid that the contractor overlook the dimensions. You need to properly arrange the reinforcement bar, design it, ensure it passes all the technical requirements, and clearly indicate that the top reinforcement bar at the support, where should the reinforcement bar stops.